Welcome back. Today I will see some example of calculus of variation which had come in different comparative exam. First example which had come in CSIR net December 2019 exam. The example is, and the question is, let x double dash t be the curve which minimize the functional zx equal to integration 0 to 1 x square t plus x dot whole square t dt, satisfying the initial condition x0 equal to 0 and x1 equal to 1. Then the value at the point half x half is, which of the following is true? Notice here the functional zx equal to integration 0 to 1 x square t plus x dot whole square t dt, and here the functional is, the variable is, since x square t plus x dot whole square t dt, here the variable is x comma t comma x dot. So here the Euler equation is different. Here the Euler equation is del f del x minus ddt of del f del x dash equal to 0, and that imply del f del x means obviously 2x minus ddt of del f del x dash means 2x dash equal to 0. That imply 2x minus 2x double dash equal to 0, and this imply m square minus 1 equal to 0. So m equal to plus minus 1, and m equal to plus minus 1, this imply obviously xt equal to c1 e to the power t plus c2 e to the power minus t. This is be the solution of this functional. With the, here the initial condition is x0 equal to 0 and x1 equal to 1. Put the value x0, then I will get c1 plus c2 equal to 0 and c1e plus c2 e inverse equal to 1, and c1 plus c2 equal to 0 implies c1 equal to minus c2. Now put the value of c1 here. This is minus c2e plus c2e inverse equal to 1. That imply, just common c2 minus e plus 1 over e equal to 1. That implies c2 equal to e over 1 minus e square. Okay, therefore just put the value c1 c2 is in this equation, then xt equal to here c1 equal to minus c2, that means here this value would be e over 1 minus e square. Therefore xt equal to c1 means e over 1 minus e square, that means this is equal to actually e over e square minus 1. c1 means e over e square minus 1 e to the power t plus c2 means here e over 1 minus e square, so just common this part minus, so this would be e over e square minus 1 e to the power minus t. This is be the solution of this functional. Okay, here we have to find the value at the point x half. So x half would be e over e square minus 1 e to the power half minus e over e square minus 1 e to the power minus half. Okay, And this value would be just common e over e square minus 1 square root of e minus 1 over square root of e. Okay, and this value equal to square root of e over e plus 1. So, option 1 is a right option. This question is different because here the variable is xt, x dash. So, the Euler equation is different. I hope my all viewers have understood. Okay. Our next example, here the functional I equal to integration x1 to x2 f of x comma y comma z comma y dash comma z dash contain this type of variable which is equal to y dash square plus z dash square plus 2yz. That means here extra variable. The necessary condition for the extremal delta f delta y minus ddx of del f del y dash equal to 0 and del f del z minus ddx of del f del z dash equal to 0. And del f del y means here 2z minus ddx of del f del y dash means 2y dash equal to 0. That means that imply 2z minus 2y double dash equal to 0. And here del f del z and del f del z means 2y minus ddx of del f del z dash means 2z dash equal to 0. That imply 2y minus 2z double dash equal to 0. Therefore, from this equation we can write here this equation implies z double dash equal to y and this equation implies y double dash equal to z. Just write this equation 1. Now put the value of 1 here. Then here for this differentiating 2 times, then this implies y to the power 4 equal to z double dash. And z double dash means obviously y. That means that imply d2 for y dy to the power 4 equal to y. Okay, and the equation would be m square minus 1 m to the power 4 minus 1 equal to 0. Therefore, the root of the equation m equal to plus minus 1 and plus minus I. Equation is yx equal to c1 e to the power x plus c2 e to the power minus x plus c3 cos x plus c4 sin x. And here the initial condition y0 equal to 0, y pi over 2 equal to 1, z0 equal to 0 and z pi over 2 equal to minus 1. For this y0 equal to 0 implies c1 plus c2 plus c3 equal to 0. And y pi over 2 equal to 1 implies c1 e to the power pi over 2 plus c2 e to the power minus pi over 2 plus c4 equal to 1. And z0 equal to other condition z0 equal to 0 and z pi over 2 equal to minus 1. For this, since z0 equal to 0 and z pi over 2 equal to minus 1, notice here I have got the condition y double dash equal to z. That means that implies z equal to y double dash. And here I have got yx equal to this. Therefore, y double dash would be c1 e to the power x plus c2 e to the power minus x minus c3 cos x minus c4 sin x. Then z0 equal to imply c1 plus c2 minus c3 equal to 0 and z pi over 2 equal to minus 1. That means this is c1 e to the power pi over 2 plus c2 e to the power minus pi over 2 minus c4 equal to minus 1. We indicate this equation as 1, this equation as 2, this equation as 3 and this equation as 4. Now adding 1 and 3. Therefore, this implies c1 plus c2 equal to 0. Now adding 2 and 4, that imply 2c1 e to the power pi over 2 plus 2c2 e to the power pi over 2 equal to 0. And since I have got c1 equal to minus c2, therefore this equal to c1 e to the power pi over 2 minus c2 e to the power minus pi over 2. Now common c1 e to the power pi over 2 minus e to the power minus pi over 2, and this is actually sine hyperbolic pi over 2, that implies c1 equal to 0. And if c1 equal to 0, that imply also c2 equal to 0. Since I have got c1 c2 equal to 0, that imply c3 equal to also 0. And since c1 c2 equal to 0, that imply c4 equal to 1. For equation of extremal which satisfy this functional is yx equal to, notice since c1, c2, c3 equal to 0, therefore yx equal to sin x, and zx equal to, since c1, c2, c3 equal to 0, that means zx equal to minus sin x. I hope my all viewers have understood this question. This question actually very important for higher studies. This type of example actually very important for any competitive exam also. Okay. Functional is yx equal to integration 0 to pi over 2 y double dash whole square minus y square plus x square dx with the initial condition y0 equal to 1, y dash 0 equal to 0, and y pi over 2 equal to 0, and y dash pi over 2 equal to minus 1. Here the functional f of x comma y dash comma y double dash equal to y double dash whole square minus y square plus x square. Notice till now I have seen all functional contain only x, y dash, this type of term. But here also contain extra term, extra higher part, y double dash. Here y double dash whole square contain. Therefore this is contain f of x, y dash of y double dash. Therefore the Euler equation of this functional is del f del y minus ddx of del f del y dash plus d2 dx2 del f del y double dash equal to 0. Then the Euler equation would be del f del y means minus 2y, del f del y dash equal to 0, and del f del y double dash means 2y double dash, that imply minus 2y plus 2. Here d2 dx2 y double dash means d4 y d x to the power 4 equal to 0, that imply y to the power 4 minus y equal to 0, and this is actually d4 minus 1 type equation, and which is m to the power 4 minus 1. And similar to before, here the root is plus minus 1 and plus minus I. Therefore the equation would be yx equal to c1 e to the power x plus c2 e to the power minus x plus c3 cos x plus c4 sin x. And here the given condition y0 equal to 1. That means c1 plus c2 plus c3 equal to 1, y dash 0 equal to 1, and that means y dash x equal to c1 e to the power x minus c2 e to the power minus x minus c3 sin x plus c4 cos x. Here y dash 0 equal to 0, that means c1 minus c2 plus c4 equal to 0. Condition is y pi over 2 equal to 0 and y prime pi over 2 equal to minus 1. Y pi over 2 equal to 0, that imply c1 e to the power pi over 2 plus c2 e to the power minus pi over 2 plus c4 equal to 0. and y prime pi over 2 equal to minus 1. That implies c1 e to the power pi over 2 plus c2 e to the power minus pi over 2 minus c3 equal to minus 1. And similar to before, consider this equation as 1, this equation 2, this equation 3 and this equation 4. Similar to before, solving, I will get c1 equal to c2 equal to c4 equal to 0 and c3 equal to 1. Therefore, the solution of this functional would be yx equal to, since c3 equal to 1 and other term is 0, therefore yx equal to cos x be the extremal of this functional. I hope my all viewers have understood. Okay. Next example, which had come CSIR net June 2014 exam. The question is, let uxy be an external of this functional. And here the functional is ju equal to double integration half uxl whole square plus half uy whole square plus e to the power xyu times dx dy, where d is the open disk in R2. Then u satisfies option 1, uxx plus uyy minus e to the power x plus y equal to 0. Option 2, uxx plus uyy equal to e to the power x times y. Option 3, uxx plus uy equal to minus e to the power xy. And option 4, double integration on the boundary D, uxx plus uyy minus e to the power xy times hxy dx dy for every smooth ace vanishes on the boundary D. Functional is f of u, ux, uy, which is equal to half uxl whole square plus half uy whole square minus e to the power xy times u. And since the functional contain here ux and uy, so the Euler equation would be such type: del f del u minus del x del f del ux minus del y del f del uy equal to 0. And this imply, sorry, here not minus, here plus. This imply e to the power xy minus del x del f del ux means obviously this imply ux del y means here del f del uy means uy, that imply e to the power xy minus uxx minus uyy equal to 0. That imply uxx plus uyy equal to minus e to the power xy. That means xx plus uyy equal to e to the power xy means that imply uxx plus uyy minus e to the power xy equal to 0. That means since this part is equal to 0, this is imply uxx plus uyy equal to plus e to the power xy, not minus. Therefore, not option 3. Option 2 is a right option. Sorry. Fourth option imply double integration uxs plus uyy minus e to the power xy times hxy dx dy equal to 0. And this is true for every smooth ace vanishes on the boundary of D. For the x plus uyy equal to e to the power xy means that imply uxx plus uyy minus e to the power xy equal to 0. That means since this part is equal to 0, so given this part is equal to 0 times any multiple of hxy with dx dy, obviously this value would be 0 for every arbitrary Smooth edge vanishes on the boundary of D. Here the value of the integration depended on D. So option 4 also right option. I hope my all viewers have understood this type of question. Okay. Oh, I will stop here. In my next video, I will discuss this type of example again, because this type of example actually very important for any competitive exam. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.